Have you ever noticed that some IP addresses start with things like 192.168 or 10.0? Those addresses work just fine on your home network, but they won't work on the internet. That's because they're private IP addresses, and they behave very differently than public ones. In this video, we're breaking down the difference between public and private IP addresses, what makes them unique, and why understanding them matters, especially in networking and cybersecurity. Let's get into it. Every device that connects to a network needs an IP address. That address identifies the device and tells the network where to send and receive data. But not all IP addresses are meant for the same purpose. Private IP addresses are used inside your local network, like your home Wi-Fi or your company's internal systems. Public IP addresses, on the other hand, are assigned by your internet service provider, or ISP, and are used for communication over the public internet. Here's the core difference. Public IP addresses are globally unique and routable on the internet. Private IP addresses are only valid inside your network, and they're not routable on the public internet. So when your laptop has an address of 192.168.1.50, it can talk to your printer, your phone, or your router, but not directly to websites or services across the internet. Now, the ranges we use for private IP addresses were formally defined in a document called RFC 1918. This document outlines three main blocks of IPv4 addresses that are reserved specifically for private use. These ranges are used all over the world, and that's okay because they're only meant for local communication only. So your home network and hospital's internal network can both use 192.168.1.anything without any conflict, as long as they don't try to directly route traffic to each other without translation. Now, routers and firewalls on the public internet are configured to drop any packets that use private IP addresses. This prevents accidental data leaks and ensures that local addressing schemes don't interfere with each other across the globe. So let's say your computer tries to send a packet from 192.168.1.100 straight to Taco Bell servers. Now, that packet won't get very far. It'll be discarded because that address isn't valid on the internet. So you might be thinking, Dave, how do private devices access the internet then? Well, they use a technique called network address translation, or NAT. NAT allows multiple devices on a private network to share a single public IP address. Your router takes care of translating internal addresses into a single public IP assigned to you by your internet service provider. It's how your phone, tablet, PC, and smart fridge all go online even though they have a private IP address. Understanding the difference between private and public IP addresses is critical in cybersecurity. If you're analyzing logs and see a source IP of 10.1.1.15, you can immediately tell it's an internal system. But if you see an unknown public IP trying to connect to your environment, that could potentially be a red flag. Firewalls, intrusion detection systems, and cloud configurations all rely on this understanding. You don't want to accidentally expose internal systems to the public internet, and you certainly don't want to allow traffic from untrusted public sources into your private network. And that's why many organizations implement strict network segmentation, isolating internal devices from external ones, and carefully control what gets NATed to a public IP. Understanding this distinction helps reduce your attack surface and improves your ability to respond to incidents quickly and confidently. Private IP addresses stay in your network, public IP addresses connect you to the outside world. Knowing the difference and how they interact is key to both managing and securing any modern network. If you enjoyed this video, please consider subscribing to the channel or check out one of the other videos on screen. Thank you so much for watching, and I'll see you in the next one. Take care.